All right, so this is going to be a video about how to multiply complex numbers, and complex numbers are just numbers that have an I in them. So the first thing I need to do is notice that it's a multiplication problem. So I'm always looking to see the symbol in between the parentheses. So without a symbol there, I know it's multiplication. And so what this tells me essentially is like a giant distributive property. So I'm going to pretend like this negative 5i isn't there. And what this is suggesting to me is that I'm multiplying the first number by the stuff that's in here. So if I make 6 and 2 multiply together, that's a 12. And then I'm multiplying 6 times a positive I, and that gives me a positive 6i. And there's nothing else for 6 to multiply with. If there was, there'd be more stuff here. But since there isn't, I only have those two kind of rainbow arrow looking things. And now I'm done multiplying. At least I'm done multiplying with the thing in the 6. I don't have anything else to do with that. So then I'm like, okay, now I can kind of go back in time and pretend that that wasn't erased. And now I'm just going to pretend like the 6 was never there. And I'm going to do the process one more time. And that's where like the smiley face looking things come from. So I'm going to multiply this times this, right? The two things that are there right next to each other. And negative 5 times 2 is negative 10 with an I. And now I've multiplied the first two things together. So now I have to multiply that 5i again with anything that might be remaining, which there is. It's that I there. So negative 5 times positive 1. So I'm looking at this negative 5, and there's a 1 right here, is negative 5. And then I've got two i's that are being multiplied. So I times I is I squared. And then I'm looking to fix any problems that are left. And so there's two types of problems I have an issue with. Like terms that are not combined. So the fact that these aren't pushed together in some sort of way, that both of them are still there, I have a problem with. It's just like having x's all over the place. I wouldn't want that. I would want them, you know, kind of just one set of them. So I'm going to fix that first. So since these two things are alike, I can just type in 6 minus 10 in my brain or in my calculator. And 6 minus 10 is negative 4. So 6i minus 10i must be negative 4i. And then I'm just going to bring down the other stuff. And I'm pretty much done. It doesn't look like any of that stuff is combinable. The one thing you have to remember is that the other issue is that I squared is worth something else. That I squared is worth negative 1. And so if you notice, again, the connection between the negative 5 and the, I don't know if I can zoom any further, there's a times symbol right here, even though you don't see it. So what this isn't really saying is negative 5i squared. It's saying negative 5 times I squared. And negative 5 times I squared is the same thing as negative 5 times negative 1. And when you multiply this negative 5 times negative 1, what you end up with is a positive 5. So we've got 12 minus 4i plus the 5. And now again, what wasn't combinable, the 12 and the 5i squared in the back, now is combinable. So 12 and 5 is 17, and 17 minus 4i is not combinable, and that's how I know my final answer. So a couple key things. Remember, I squared is negative 1. So if I have 5i squared, that I squared will turn that 5 into a negative 5. And if I had a negative 5i squared, that I squared would turn that negative 5 into a positive 5. Some other random things to remember. 10i plus 5i is 15i, not 15i squared. 10i squared plus 5i squared would be 15i squared. So when you're adding things together, the stuff that's the same stays the same. Apples plus apples is still apples, not apples squared. So think of i's as i's, not I squareds, right? The only time you get an I squared is when you are multiplying. I times I, just like when you have x times x, is x squared. So I times I is I squared. So when there's multiplication of two i's, you get an I squared. But when you're adding them, it's just things that are the same stay the same. All right, hope that helps.